Welcome back to another video. So today we'll be going through the 2020 Mathematics Advanced HSC examination. So before we do get into it, just quickly a reminder, you have 3 hours for your working time and only 10 minutes for your reading time. So make sure you use those 10 minutes wisely, go through the multiple choice, see what you can answer before you actually start the test. And then also make sure you are looking ahead through the more difficult questions in the exam to see if you can identify any of the really tricky problems that you might need to spend a bit more time on later on. Okay, 100 marks in this exam for 3 hours, so that should allow us about 1.8 minutes, so keeping it just underneath 2 minutes for each mark in this exam. With that being said, let's dive right in and start on multiple choice. Question 1. So, which inequality gives the domain of y equals the square root of 2x minus 3? Okay, so when we're looking at this inequality and the domain within this, well, we need to know that we can never take the square root of a negative number. So what we can say from that then is that 2x minus 3 must be greater than or equal to 0. We can take the square root of 0, it's simply 0. So solving now for x, we'll add 3 to both sides and then divide by 2. And then we're left with x greater than or equal to 3 over 2. And there we are. So that is option D. Okay, moving on now to question 2. So the function f of x equals x cubed is transformed to g of x equals x minus 2 cubed plus 5 by a horizontal translation of 2 units followed by a vertical translation of 5 units. So which row of the table shows the direction of the translations? Okay, so firstly, let's begin with that horizontal translation. We should know by now that if we take maybe the x minus 2, as we have done here, then we know that that's just going to be shifting it to the right by 2 units. So if you're not fully comfortable with that yet, I would really highly recommend you go and check out Desmos, the online graphing software, and you can probably go and try mucking around with all these different functions and see exactly what happens. But we should be fairly comfortable with that sort of stuff by now. So we know that that will be shifting it to the right. So we now know that our options are between B and D. And then let's see, if we add 5, well, that's just going to shift it upwards by 5. And so we see that question 2 will be B. Now, on to question 3. So John recently did a class test in each of 3 subjects. The class scores on each test were normally distributed. The table shows the subjects and John's scores as well as the mean and standard deviations of the class scores on each test. So there's his French, commerce and music scores and all the information there. So relative to the rest of the class, which row of the table below shows John's strongest subject and his weakest subject? Okay, so to determine that, what we should do is go through and work out the z-score of each of his individual test scores. So just a quick reminder, our z-score formula is z equals x minus mu all over sigma. And so they've set it out very nice for us because it's simply our x, our mu, our mean, and then our sigma, the standard deviation. So 82 minus 70 is going to be 12. 12 divided by 8 is simply 1.5, so that's the z-score of French. Now for commerce, 80 minus 65 is 15. 15 divided by 5 is 3. 74 minus 50 is going to give us 24. 24 divided by 12 is 2. So we can say that his strongest subject is going to be commerce, and his weakest subject is going to be French. So our option here is A. Now, even though his marks don't necessarily reflect that French is his weakest subject, in comparison to the rest of the class on all the other tests, that is his weakest subject. Okay, now on to question 4. So what is the integral of e plus e to the 3x dx? Okay, so good thing they've all included our plus c terms. That's the one thing that we never ever want to forget. Okay, so the integral of e, remember e just taken by itself is just a number. So the integral of that will be ex. So clearly it's not going to be c or d because that just remains as an e term there, and that's not quite correct. So now e to the 3x, well, the integral of that, let's see, we need to divide by that power there, so that 3 will be dividing by 3 there. So our option there is going to be B. Okay, so moving on to question 5. So which of the following could represent the graph of y equals minus x squared plus bx plus 1, where b is greater than 0? So that's going to be a little bit of an indicator here as to what's going on. So let's have a quick think about what we know. So minus x squared. So that means it's going to be concave down. So right away we can eliminate options A and B. So at this point in time you have about a 50-50 shot. And let's see, what else do we know? We know that there's +1, so that's going to be our y-intercept. So luckily, all of these are satisfying that +1 y-intercept. Okay, so now since that b is going to be greater than 0, well, we know that it's actually going to then tend more towards the positive side. And so again, as I was mentioning earlier on question 2, I believe, this is one of those things where you should be probably playing around with Desmos or some other sort of graphing software to become comfortable with the changes that a change in sign can make on a different, a very varying functions. So you should be pretty comfortable with your quadratics, your parabolas, that is, your cubics, your sine, cosine, your hyperbolas, exponentials, and logarithms. I might be forgetting a few, but I think that's the majority of the graphs that you should probably know before going into your HSC. So our option here will be 5C, and there we are. Now, on to question 6. So which interval gives the range of the function y equals 5 plus 2 cos 3x? Okay, so the only thing that matters here realistically is that amplitude of the cosine there. So the amplitude is 2. Now the frequency is 3, but we don't really care about that at the moment. We're just looking for the range of this entire function. So that means this can go from -2 all the way up to +2. So that could then bring us down from 5 minus 2, so it could be at lowest 3, or it could be 5 plus 2, all the way up to 7. So 3 to 7 is going to be our interval there. Okay, now moving on to question 7. The diagram shows the graph y equals f of x, which is made up of line segments and a semicircle. So what is the value of the integral from 0 to 12 of f of x dx? So with a problem like this, the key idea to note is the symmetries that we've got going on. So we notice that there is this line here that goes from 8 down to 10 and then 10 down to 12 with the exact same gradient. And we see that this area is going to be equal to this area exactly. So those will perfectly cancel out. So realistically, the only area that we actually need to calculate and are worried about is going to be this rectangular section here, this rectangular section here, and this semicircular section there. So let's figure out all of those now. So we know the area is going to be equal to, well, it's how tall is this rectangle? It's, I might quickly label these, A1, A2, and A3. So we can say that the whole area is A1 plus A2 plus A3, and this is sort of a general procedure for you working out, not necessary in multiple choice, but probably more helpful later on in the exam if necessary. So let's have a quick look. So A1 is simply, well, 3 times 4, so that's 12. A2 is again going to be 3 times 4, so A2 is 12. And now A3, so formula for the area of a circle is pi r squared, but here we have a semicircle, so it's going to be half pi. Now the radius here, well, the diameter is 4, so the radius must be 2, so 2 squared. Okay, and we see that there's a half down here, and that'll actually help cancel out one of these 2's, so we can just get rid of those. And we end up with 2 pi for our area 3. So that means that the total area is going to be equal to 24 plus 2 pi. And that leaves us with option A. Okay, now on to question 8. So the graph of y equals f of x is shown, and then it's asking us about a few different features of this graph and its derivatives at that point there. So sometimes a problem like this, you might be okay to just kind of look at the general shape of the graph, and then you might be able to sort of guess exactly what's going on here. For something like this, I would actually encourage trying to think a little bit harder about what this function might actually be. So you probably recognize that this looks somewhat like a logarithm function, and so you'd be correct in saying that this, I believe, is going to be the logarithm, ln, of x plus 1. Okay, so the logarithm of x plus 1, and so what that means now is we can actually just test the different values. So I'll quickly replace that as f of x equals ln of x plus 1. And okay, what about the first derivative of that? Well, the first derivative of that is now just going to be 1 over x plus 1. And the second derivative, so now taking the derivative of that function there, so f double prime of x, well, that's going to be equal to essentially minus 1 over x plus 1 all squared. Okay, so now let's start looking at the values. So f of 1 is going to be equal to the natural log of 2. So ln of 2, which is in your calculator about 0.69. Now f prime of 1, that's our next one to figure out. So f prime of 1 is going to be equal to, pretty simply, 1 over 2. And now for our f double prime, so our second derivative of 1, that's just going to be equal to, let's see, minus 1 over, and again now it's going to be 1 plus 1, so 2 squared, so 4. Okay, so now we have the different values there. So what we can see now is that f of x is about 0.69. This is going to be 0.5, so clearly f of x at 1 is greater than f prime of x at 1. And then we have clearly that both of those are greater than f double prime at 1, since this is negative. And so what we find, actually, when we start looking at all of our different options here, is that option A describes this situation perfectly. Because f double prime at 1 is a negative value, so it's less than 0. So that's correct, that's correct. And then we know that f prime at 1 is 0.5, so that's correct. It's greater than 0. And now we know that f of 1 is about 0.69. So that is correct as well. And there we are. So now on to question 9. So suppose the weight of melons is normally distributed with a mean of mu and a standard deviation of sigma. A melon has a weight below the lower quartile of the distribution, but not in the bottom 10% of the distribution. Which of the following most accurately represents the region in which the weight of this melon lies? Okay, so the key idea here is that it's in the bottom quartile, so that means it's in the, lower than the 25th percentile mark, but it's greater than the 10th percentile mark. Okay, so this is very dodgy notation here, by the way, but I am going to go with this. So it's greater than the 10th percentile, but less than the 25th percentile. So what we should know is from our empirical rule that this is going to be about 34% within one standard deviation either side. So that's 34% there. That's 34% there. Then I believe it is a 16% is essentially drawn out through the rest all the way down here. And I believe this is actually around I want to say a 13.5, I might be wrong, 13.5-ish percentage. It's something like that. So what we can do now is identify, well, which of these make absolutely no sense? Well, clearly the first option makes no sense because that would indicate something within the bottom 10%. So that makes no sense. That definitely does not do us because we know that if you're at this point here, then you're already in the about 2.5th percentile. So that's no good. Okay, and similarly with B, that's no good. And now for C, well, it's looking a little bit better, and in fact it is. It's 100% better because now we see that, well, this is probably the area where the 25th percentile is, and then this would appropriately be the 10th percentile. So that actually works out very nicely for us. And we can see that D is also not going to make any sense because now this is a bit too far down to be included in that less than the first quartile remark there. So that is also incorrect. So by elimination or simply by knowing what this should look like, you can get to option C fairly straightforward. Okay, question 10. The graph shows two functions, y equals f of x and y equals g of x. So we are going to define h of x equals to f of g of x. How many stationary points does y equals h of x have for 1 less than or equal to x less than or equal to 5? Okay, so this is a very tricky question here. I don't believe very many people got this question correct. And so let's have a quick look at this and the method that I would take. So I'm not sure if there are other methods to approach this question. Perhaps there's some theorem that starts defining, the stationary points within a function of a function. But for me, what I found useful was simply to look at the values that y equals g of x takes across the domain 1 through to 5. So let's look at this parabola first. We know that when x is 1, g of x is 2. Okay, so we have g of x over here at 2. Then when x is equal to 2, g of x is equal to about 0.5. So I'm going to write these down. So we go from 2 to 0.5. And then what else do we go to now? We go to 0. And then we go all the way back up to, well, since it's a parabola, it's going to be symmetric, so 0.5, and then back up to 2. So this is essentially, we can quickly model this with a little table. So our x values, so 1, 2, 3, 4, 5. This is going to be our g of x values. And now what we should do is we should start thinking about our f of g of x. Okay, so realistically our h of x, but I'm going to write it as f of g of x. Because what this will let us do now is it will let us think about, well, what happens on the f of x graph, so this funny looking curve here, what happens on that when we have these different inputs? So when x is equal to 2, we have on the f of x function a value of about, I'm going to guesstimate about 1.5 perhaps. So we have a value of 1.5 there. Now, when we would have an input of 0.5 on f of x, what do we get? We get a value of about, I want to say, let's say that's about a 2, perhaps. So we would say that goes into a 2. And now when we have a value of 0 being represented, well, that would now be over here at this point. So when you input 0 into f of x, you get about, let's say, 1.8. So now what else do we have now? So 0.5, well, we've already seen that. That now gives us the 2, and then the 2 will give us the 1.5. So what we can do now is quickly graph this up and see exactly what we get. So we know 1, 2, 3, 4, 5. And we know we're going to be working from, let's say, 1, 1.5, 2. I'll quickly put those in there now. Okay, so when x is 1, f of g of x is 1.5, so right around there. When x is 2, f of g of x is similarly 2. When x is 3, f of g of x is about 1.8. So I'm going to put it right in the middle there. And then we know that it's going to be, once again, symmetric. So that will bring up this point here. And now, again, down at the 1.5-ish mark. Okay, so what we need to do now is we need to look at the sort of the trend of this function, and we can see that it would look something like this. And it should continue downwards as such. Okay, we don't actually know what will happen with this whole function because we don't really know what the left-hand side of this function might look like. It might just go 0, or it might go suddenly back up. We don't know. So what we do know, however, is that there's going to be 3 stationary points within this function. 1 here, 1 here, and 1 here. That's a local maximum, local minimum, local maximum. And there we go. So our option for question 10 is going to be D, for the 3 different stationary points that we can see on this function there. And that concludes the multiple choice section for this paper. Now let's get a head start on to question 11. So there are 2 tanks on a property, tank A and tank B. Initially, tank A holds 1,000 litres of water and tank B is empty. So tank A begins to lose water at a constant rate of 20 litres per minute. The volume of water in tank A is modelled by the equation V equals 1,000 minus 20T. I'm just going to write that down separately as well, where V is the volume in litres and T is the time in minutes from when the tank begins to lose water. So on the grid below, draw the graph of this model and label it as tank A. And what I might do with our equation here, I might just label that V sub A, so that way we know which tank we're talking about here. Okay, so we know that it starts with 1,000 litres in it, so that means we'll have a y-intercept over here at 1,000. Now, how long would it take to drain to be empty if it's decreasing by 20 litres per minute? So what we need to do is just solve for when V equals 0, and we find that T should equal to 50. So all we have to do now is connect these 2 points, and that will be our line of V equals 1,000 minus 20T. And there we go. So in reality, make sure you use a ruler when doing a question like this, but that should be fine like this for now. So we'll quickly label that tank A. Okay, there we are. So that's part A done. Now part B. Tank B remains empty until T equals 15 when water is added to it at a constant rate of 30 litres per minute. Okay, by drawing a line on the grid on the previous page or otherwise, find the value of T when the two tanks contain the same volume of water. So it will be empty until T equals 15, so we know that we will be starting from that value there. And then it's going to go up with a gradient of 30 or so. So it should look something like that. And that's going to be tank B. Okay, so what we'll do is we'll now construct an equation for tank B. So we know that it is going to be equal to, well, what does it start at? What's our y-intercept? Well, we don't actually know that yet. So in order to figure that out, what we need to do is we need to sort of project this down until we could get to that y-intercept point there. And so what we'll then find is that the y-intercept for that equation is going to be equal to minus 450. And then we will have a gradient value of 30t. So that's just coming straight from this equation here, where it's filling up 30 litres per minute. Okay, so now we want to find out when they both have the exact same amount of water. So according to my graph, it should be around 31 minutes, but that's looking a little bit dodgy, simply because I did do this by hand. So what I'd recommend we do now is just solve these two as simultaneous equations. So we know that volume A must now equal to volume B, so therefore we can say that 1000 minus 20t must be equal to minus 450 plus 30t. Okay, so let's solve for t now. So we'll add 20t to both sides and then add 450 to both sides. So we're left with 1450 is going to be equal to 50t. And so now solving for t, we get that t is going to be equal to 29. There we are. So that's the time at which point both tanks have the exact same volume of water after 29 minutes. So our graph wasn't too far off, only 2 minutes off there. However, still would be the incorrect answer. So yeah, always better to check with the algebra. Okay, now part C. Using the graph drawn or otherwise, find the value of t, when t is greater than 0, when the total volume of the water in the two tanks is 1000 litres. Okay, so what that means now is that when I add the water from tank A to the water from tank B, it must be equal to exactly 1000. So all we need to do now is simply construct, well, using those two equations, construct a new equation, saying that VA plus VB is going to be equal to 1000 litres. So now substituting in the other values for VA, which is 1000 minus 20t, and now for VB, it's going to be plus minus 450, and then plus 30t. So that's going to be equal to 1000. Okay, so now all we need to do again is just quickly solve for t. So then we'll have 30t minus 20t is 10t, and then 1000 minus 450 is 550. So we'll quickly say 10t plus 550 is equal to 1000. And then again, solving for t, minus 550 from both sides, and we'll get 10t equals 450. And then lastly, quickly dividing both sides by 10, we get that t is equal to 45. And that's part C done. So that's when both tanks will be added together to get a total volume of 1000 litres. All right, moving on to question 12 now. So it asks us to calculate the sum of the arithmetic series 4 plus 10 plus 16 plus ... all the way up to 1354. So whenever we're calculating the sum of an arithmetic series, what we need to do is use our formula. S sub n is going to be equal to n over 2 times by a1 plus an. So we know that we're looking for S sub n, so that's the sum of the entire series. We know a1, because that's simply the first term, which is 4, and we know an, which is going to be 1354, since that's the nth term in this series. But what we don't know is actually what is n. So if we know n, then we can finally figure out what the sum of this entire series is going to be. So in order for us to then figure out n, we can use our other formula, such that an is equal to a1 plus n minus 1 times by d, the common difference. So the common difference here is just how much does it increase by each step. So 4 to 10, 10 to 16, so clearly the common difference here is 6. So again, quickly solving now for n from this equation. So we can say 1,354 is going to be equal to 4 plus n minus 1 times by 6. Okay, so now we can just simply start solving for n from this equation here. So we'll minus 4 from both sides and then divide both sides by 6. So we'll end up with 1,350 over 6 is going to be equal to n minus 1. And so 1,350 is, divided by 6 is going to give us 225. So then we'll add the 1 to that, and we can say, therefore, n is equal to 226. So now substituting that value of n back into this expression that we had written up earlier, now we can say that it's going to be equal to 226 over 2 times by 4 plus our nth term, which is 1,354. And so when we sum that, we find that the sum of this series is going to be 153,454. And that's our final answer there. Okay, so now moving on to question 13. So evaluate the integral of sec squared x dx from 0 to pi on 4. Okay, well, hopefully we know and recognize that the integral of sec squared x is simply just going to be equal to tan of x. Okay, and so now all we need to do is just sub in our values of pi on 4 and 0. So then we get that it's equal to tan of pi over 4, which is essentially tan of 45 degrees, which is 1, minus tan of 0, which is going to be 0. So then our answer here is simply 1. That's question 13. Okay, moving on to question 14 now. So history and geography are two of the subjects students may decide to study. For a group of 40 students, the following is known. So 7 students study neither history nor geography. 20 students study history, 18 students study geography. So a student is chosen at random. By using a Venn diagram or otherwise, find the probability that the student studies both history and geography. Okay, so let's use that Venn diagram and let's quickly draw one up. Something like this. And so we know that there's going to be 7 students that study neither history nor geography. So we'll just put that up there in the top right corner for now. And now we'll make our 2 different circles here. So we'll say that the geography is on the left and history is on the right. And what I think we should do is probably label each of these sections now. So we'll say that X people study only geography, Y people study both geography and history, and Z number of people study only history. So what we can say now is that X plus Y plus Z must be equal to 33, since we know that there's 40 students in total, and we know that there's 7 on the outside, so that means there's 33 left over in these 3 different sections here. Okay, what else do we know? We know that there's 18 students that study geography, so we can also say, therefore, that X plus Y equals 18. And we know that 20 people study history, so now we can say that Y plus Z is equal to 20. So let's quickly work with these 2 equations here. So let's work with, we'll quickly label these, so 1, 2, and 3. So now with equation 2, we can then rewrite that as X equals 18 minus Y. We'll call that equation 4. And we can also write from equation 3 that Z is equal to 20 minus Y. So what we can do now is we can rewrite equation 1 simply in terms of Y, our variable. So now rewriting Y, we can see that instead of X, we'll write 18 minus Y plus, now it's just Y, and then plus Z, so that now becomes plus 20 minus Y equals 33. And so what we get here is that it will become 38 minus Y equals 33. So we can say pretty clearly, therefore, Y equals 5. So we know that exactly 5 people study both history and geography. So now if we look back at the question, what does it ask us? It says, by using a Venn diagram or otherwise, find the probability that the student studies both history and geography. Okay, well, if they are in that little part there, we know that it's going to now be a probability of 5 out of how many people are there in total? 40. So we can simplify that to now just being 1 over 8. And that's our answer for part A. Now for part B. A student is chosen at random. Given that the student studies geography, what is the probability that the student does not study history? So given that they study geography, what's the probability that they do not study history? So let's write that out using some proper notation. So they do not study history, so we'll write that like that, given that they study geography. Well, let's have a quick look at some of our numbers over here. So x, the number of people that study geography, well, let's quickly work that out. Since now we know y, we can say that x plus y equals 18. And since y is 5, we now know that x is going to be 13. And then from equation 3, we know that y plus z equals 20. So now that means that z must be 15. Okay, so now let's have a quick look at this. So if they study geography, that means that there's a total of 18 people that study geography. Okay, so that means that now we're going to be looking at the fraction out of 18 people in total. And now, what portion of those 18 people do not study history? Well, it's just going to be 13 of them, because only 13 out of those 18 people that study geography do not study history. That's part B. So part C says 2 different students are chosen at random, one after the other. What is the probability that the first student studies history and the second student does not study history? Okay, well, we know that there's 20 students all up that study history. So what we can say then is for the first student, there will be a 20 out of 40 chance of them actually studying history. And then for the next student to not be studying history, well, how many students don't study history all up? There's 20 of them. But now we're going to be selecting that person from 39 different people, since we've already selected one from the pool of 20 people that study history. And so we can then simplify that to now just equal to 10 over 39. And that's our answer for question C. Okay, now moving on to question 15. So, Mr. Ali, Miss Brown, and a group of students were camping at the site located at point P. Mr. Ali walked with some of the students on a bearing of 35 degrees. So let's quickly draw that in. So that means that this is 35 degrees on a bearing of 35 degrees for 7 kilometers to location A. Okay, and Ms. Brown with the rest of her students walked on a bearing of 100 degrees for 9 kilometers to location B. So quickly putting that in, that means that entire angle there is going to be 100. All right. So now for part A, it says show that the angle APB is 65 degrees. So as I've pretty much just shown us there, APB is going to be equal to 100 minus 35. And let's make sure that these are all in degrees, equals 5 degrees. And there we are. So that's all there is to part A. It's really just that simple. So now it asks us for part B, find the distance AB. So let's just quickly draw that in. So that's what we're looking at now. All right, so what we know is that this angle here is 65 degrees. And so what we recognize that we can use here is going to be our cosine rule. So our cosine rule, just as a quick reminder, is c squared equals a squared plus b squared minus 2ab cos of the angle C. Okay, so now let's quickly write everything in. So we know that C must then be equal to the square root of, so let's say A is going to be maybe the 7 kilometer side. So we'll write 7 squared plus, and then B must be the 9 side. So 9 squared, and then minus 2 times A, which is 7, times B, which is 9, times by cos, which is that internal angle between sides A and B, which here is going to be 65 degrees. And there we are. So once we put that into a calculator, we find that length AB is going to be equal to 8.76 kilometers. And we'll write that that is equal to the length of AB. Okay, now for question C. Find the bearing of Miss Brown's group from Mr. Ali's group and give your answer correct to the nearest degree. So what I might do here is I might actually just quickly redraw this out so that way we can see it in a little bit more detail as to exactly what has gone on here. So what we know is that this is our north line, this is point A. I might draw that over there. We know that this is point P, we know that this is point B. So what we're looking for now is going to be this angle here. Let's call that theta. So what else do we know? We know that this is 35 degrees. So since these are now two parallel lines, that means we've got a transversal line going through here. That must mean now that this angle here is going to be 180 minus 35, so 145. Okay, so now all we need to do to figure out our angle theta is to simply figure out, well, what is this angle from that point there? So to figure that out, what we can use is we can use the sine rule. Since we know that this side length is 7 kilometers, we know that this side length is 9 kilometers, and we now know that this side length is 8.76 kilometers. So now, in order for us to figure out this angle here, let's call that angle phi. What we'll do is, I'll write this down below, is we'll say that sine of phi over 9 is equal to sine of 65 degrees over 8.76. And so all we need to do now is quickly solve for phi. So we see that phi is going to be equal to now sine inverse of 9 sine 65 degrees over 8.76. And there we are. So now when we actually compute that, we get that phi to the nearest degree is going to be 69 degrees. Okay, so now all we need to do is figure out theta. So theta is simply going to be equal to 360 minus 145 minus 69. So we can therefore say, down the bottom here, we'll say that theta equals, as I've said, 360 minus 145 minus 69 degrees. And make sure these are all degrees. And then that is equal to 146 degrees. And that's question 15, all done. Okay, now on to question 16. So it asks us to sketch the graph of the curve y equals minus x cubed plus 3x squared minus 1, and labeling the stationary points and the points of inflection. And we do not determine the x-intercepts of the curve. Okay, so let's quickly write out our equation over here. So y equals minus x cubed plus 3x squared minus 1. And what we'll do is, anytime we're looking for stationary points, obviously we must work out our first derivative. So we know now that that's going to be minus 3x squared plus 6x. Okay, and whilst we're at it, let's figure out our second derivative, just in case we need it. So we can say that's going to be equal to minus 6x plus 6. Okay, so now to figure out our stationary points, what we need to do is set the first derivative equal to 0. Let's do that over here. So setting y prime equal to 0, what we get is that therefore 0 must be equal to minus 3x squared plus 6x. So what we can do here is just quickly solve and see what this can now factorize out to become. So I'll add the 3x squared to the other side, so that way it's positive, and then minus the 6x from both sides. That way we can just quickly write that out as 3x squared minus 6x equals 0. It's a little bit nicer to look at now. So now there's a common factor of 3x on both of these terms here, so we can take those out. Now we'll read 3x outside of x minus 2 equals 0. So we can say, therefore, x equals 0 or 2. So what does that mean now? That means that there must be stationary points at those two values of x. Okay, so what we can do now is to quickly check the values at those stationary points. So let us check y prime of, y double prime of 0, and what do we get? We get that it's going to be equal to minus 6 times 0, so 0 plus 6, which is greater than 0, so therefore that's going to be a local minimum. Okay, so that way we know there's a minimum at x equals 0. And what about y double prime of 2? Well, we know that that is going to be equal to minus 6 times 2, so minus 12, plus 6. That's equal to minus 6, which is less than 0. So we can say, therefore, it's a local maximum. Okay, fantastic. So what we should do is actually figure out the coordinates of these 2 points now. So looking at our minimum point, well, it's at 0. So that's actually just going to end up being our y-intercept, since we know that y of 0 is just going to be equal to 0 plus 0 minus 1. So that means we can say now minimum at, and let's write that in bracket, in coordinate notation, 0 minus 1. Okay, now what about our maximum? So y of 2, that's going to be equal to minus 8 plus 3 times 4, so 12, minus 1. So that will give us a value of 3. So we can say, therefore, max at, and that was at 2, 3. Okay, fantastic. So now we've got our 2 stationary points there. So let's quickly draw up our Cartesian plane as such. And let's quickly draw those 2 points in. So we know we have 0, minus 1. And we also have somewhere over here, 2, 3. But we know that if we've got a minimum over here and a maximum over here, then we should most likely have an inflection point right in the middle here. So the inflection point will occur right in the middle of these 2 points here at 1, 1. So just by taking the average of these 2 positions. Now this doesn't necessarily work for every type of function, but with a polynomial like this, it's going to be fairly predictable. So we can put that point in here now as 1, 1. Okay, so all we need to do now is just quickly graph these. So we see that we have that minimum there, and then going into the inflection, and then the maximum before it then starts going back down into the negative. And there we are. So that's question 16. Okay, now on to question 17. So simply integrating x over 4 plus x squared. Well, we should recognize that this is going to be a logarithmic integral. So simply writing this out, well, all we need to do now is just, I'll rewrite it in the preferred form of the x squared coming first. And, well, simply, we notice that if I was to differentiate the bottom, it would be 2x. So remember, when we're integrating a function like this, and it looks like we have the derivative on the numerator and the primitive on the denominator, then it's going to be a logarithm. But what we need to know here is that there's no factor of 2. So now when we write this out after integrating, it's now going to be the half times the natural log of x squared plus 4, okay? Since there wasn't any 2 in the numerator there. And now don't forget, plus c. And that's question 17. So now to question 18. So differentiate e to the 2x times by 2x plus 1. So we need to know our product rule here. So y prime is going to be equal to e to the 2x. Sorry, I'll write this out. So u prime v plus uv prime. And so I know that u is going to be equal to e to the 2x. U prime is equal to 2e to the 2x. I know v is equal to 2x plus 1. And v prime is just equal to 2. Nice and simple. So now subbing these values all back into that product rule equation, so we can say that the derivative now is going to be equal to simply putting those values in. We get 2e to the 2x times by v, which is 2x plus 1, and then plus u, which is e to the 2x times by v prime, which was 2, so I'll just put that out the front there. And what we recognize we can do now is we can actually just take out the common factor of 2e to the 2x, and we can then rewrite this as 2e to the 2x times by 2x plus 1, and then plus 1 for that last term on the end there. So now simplifying that, plus 1, we can rewrite that now as simply plus 2. And now we see that we've got a common factor of 2 on the inside of the bracket here. So that must now be equal to 4e to the 2x times by x plus 1. And that is it in its simplest form. So that's question 18, part A. Now for part B, it says, hence, find the integral of x plus 1 e to the 2x dx. So that looks very, very familiar to what we've just looked at here. So the only difference here now is that there's a factor of 4. So what that means now is when we integrate this function here, x plus 1 e to the 2x dx, that just means that we need to have a factor of 1 over 4 out the front to cancel that. So we can say 1 over 4 e to the 2x times by 2x plus 1. And then don't forget, plus c. Okay, that's question 18. Now for question 19, prove that sec theta minus cos theta equals sine theta tan theta. So what I think we need to do for all these sort of questions is to write it out in just sine and cos. So that way you can really see what's going on. So sec theta, that's just going to be 1 over cos theta minus cos theta equals, so sine times tan, that's going to end up being sine squared theta over cos theta. Now what we should do is multiply everything by cos theta, so that way we'll end up with 1 minus cos squared theta is equal to sine squared theta. And so now if we add cos squared theta to both sides, well, now we see that we have 1 equals sine squared theta plus cos squared theta. And that's a given formula that we should know by now, and I believe it might also be on your formula sheet. Okay, so that's question 19. Now moving on to question 20. So Kenzo is driving his car along a road while his friend records the velocity of the car, vt, in kilometers per hour every minute over a 5-minute period. The table gives the velocity v of t at time t hours. So the distance covered by the car over the 5-minute period is given by, so we have this integral here from 0 to 5 over 60 of v of t dt. So what we want to do is use the trapezoidal rule and the velocity at each of the 6 time values to find the approximate distance in kilometers the car has traveled in the 5-minute period. Give your answer correct to 1 decimal place. Okay, so what I think we should do is quickly draw up a graph as to what this looks like. So we know that we'll have 1 minute, 2 minute, 3 minute, 4 minute, and 5 minute. So this will, I'll write these out as 1 over 60, 2 over 60, 3 on 60, 4 on 60, and 5 on 60. And then we know that we have a few different values. So let's say we've got 60 here, maybe 55 here, and then we'll just arbitrarily kind of put maybe a 70 up here. I'm not too fussed about this right now, but we just want to get the general idea as to what this will look like. And that's going to be just 0 at our origin there. So we know we're going to start at 60, and then we'll go down to 55. Then we'll go back up now to 65, and then up a little higher to 68, and then up to 70, and then back down to 67. So we know this now would look something like this. Let's connect those dots. And what we can do now is just drop these down. And so now you can probably see that it actually makes for a pretty good use of the trapezoidal rule, since these actually do all form trapezoids, since this is a linear graph. Okay, so trapezoidal rule, we should know that it's just the area of the trapezoid of a trapezium, so h on 2 times by a plus b. So here the height is actually just going to be the distance on the x-axis, so it's just going to be 1 over 60. So what we'll do now is write 1 over 60, and then it's half of that. So what we can do, in fact, for all these is just write 1 over 120. And now, putting in the different values, so 60 plus 55 plus 1 over 120 times by 55 plus 65 plus 1 over 120 times by 65 plus 68. Now, there are quick ways to do this, but doesn't hurt to be a little bit thorough, plus 1 over 120 times by 68 plus 70, plus 1 over 120 times by 70 plus 67. So just putting in all of our different y values for the for the y positions that are next to each other. And so when we calculate all that, well, we find that A, the area underneath the curve, is going to be equal to about 5.358. So now rounding that to the nearest decimal as asked, we can say that therefore 5.4 kilometers. And that's how far we have traveled in those 5 minutes. All right, and that was question 20. Okay, now on to question 21. Hot tea is poured into a cup. The temperature of tea can be modeled by capital T equals 25 plus 70 times by 1.5 to the negative 0.4 lowercase t, where capital T is the temperature of the tea in degrees Celsius, and lowercase t represents the number of minutes after it is poured. So part A asks us, what is the temperature of the tea 4 minutes after it has been poured? Well, all we need to do now is just sub that lowercase t equals 4 into our expression. And so what we'll get now is capital T for the temperature is equal to 25 plus 70 times by 1.5 to the negative 0.4 times by 4. And so when we put that into our calculators, we should get about 61.59 degrees Celsius. And that's our answer for part A. Now for part B, at what rate is the tea cooling 4 minutes after it has been poured? So all that's realistically asking us to do is we need to figure out our first derivative at the time where t equals 4. So let's quickly figure out our first derivative, and then we can make that substitution. So dt on dt is going to now be equal to 70 times by minus 0.4, bringing that down from the index there. And now it's also going to be times by the natural log of 1.5, so that base number there. And then again, finally, times by 1.5 to the power of minus 0.4 t. Okay, so now all we need to do here for this actual question is just rewrite this out now as dt on dt of 4. So all we do now is just instead of putting a lowercase t in here, replace that with a times by 4. And then putting that into your calculator, you will get a value of minus 5.93. And now we need to interpret that. So what does that mean? So this is the rate that the tea is cooling 4 minutes after it has been poured. So what we can say here is that is going to be measured as minus 5.93 degrees Celsius per minute. And the way that we'll write that is minute to the negative 1. Okay, and that's part B. So now moving on to part C. How long after the tea is poured will it take for its temperature to reach 55 degrees Celsius? Okay, so using our original formula, all we need to do now is replace the capital T with 55. And then we'll solve for lowercase t. And so doing that, let's have a look at what we get. So 55 equals 25 plus 70 times by 1.5 to the minus 0.4 t. So now let's subtract 25 from both sides. What do we get? Well, we'll simply get 30 equals 70 times by 1.5, again to the minus 0.4 t. Okay, and now what we should do is divide both sides by 70, and then we'll have 1.5 to the minus 0.4 t equals to 3 over 7. And now what we want to do is take the natural log of both sides, so that way we can bring this down, and we can say that minus 0.4 t times the natural log of 1.5 is equal to the natural log of 3 over 7. And simply now solving for t by dividing both sides by minus 0.4 and the natural log of 1.5, well, what we find is that t is now going to be equal to the natural log of 3 on 7 divided by minus 0.4 times by the natural log of 1.5. And so that will give us a t value of approximately 5.22 minutes. So to get it into minutes, make sure you hit the degree minutes second symbol on your calculator after you've plugged those numbers in, and then it will tell you your answer is just 5.22 minutes. Okay, so that was question 21 there. Now on to question 22. So question 22 actually looks deceptively easy, to be honest. However, a lot of students really struggled with this question when this came up. So the diagram shows a regular decagon, so a 10-sided shape with all sides equal and all interior angles equal. Now the decagon has center 0, or O I should say. The perimeter of the shape is 80 centimeters. Now by considering triangle OAB, calculate the area of the 10-sided shape. Give your answer in square centimeters, correct to 1 decimal place. Okay, so what we need to start with here is probably a very old sort of formula that you probably haven't seen since maybe like year 8, 9, or 10, which is this formula here. So n minus 2 times by 180 degrees, that is going to equal to the total internal angle. It's So in other words, what happens when you add up every single angle at each corner inside this shape. So n is going to be the number of corners or number of edges here. So in this case, it's a 10-sided shape, so n is going to be equal to 10. So what that means now is that the total internal angle for this decagon is going to be 10 minus 2, so 8, times by 180 degrees, and that will give us a value of 1,440 degrees. Okay, so that means now that if I add up every single angle going around this decagon on the inside, I know that they will add up to give us 1,440. So what does that mean is the angle now at each individual section? Well, we've got 10 different angles to consider, so all we need to do is simply divide that by 10, and that will tell us each individual angle size. So what I might quickly do is just label one of these angles there somewhat arbitrarily, and we'll just note that that is 144 degrees. Okay, but what do we notice about this side length OA and also OB? We notice that they bisect the angle. So that actually means that they just cut this angle in half. So now, if I was to look at the angles inside of that triangle, what I can say is that the angle OAB is going to be equal to the angle OBA, which we know to be true since it is an isosceles triangle. And that is in fact just going to be equal to 144 divided by 2, or in other words, simply equal to 72 degrees. Okay, so now we know those two angles here in our triangle are both going to be 72 degrees. Awesome. So what does that mean that our angle AOB is going to be? So our angle AOB, so that's the one right from the origin there, that's now just going to be equal to 180 degrees minus 72 minus 72. And so that will give us an angle of 36 degrees. Okay, so we've actually done a good amount of work here so far on this question. Now there's one other thing that's given to us in this question here. It says that the perimeter of the shape is 80 centimeters. And since we know that all the sides are the exact same size, and there's 10 sides, well that means that length AB must be equal to 8 centimeters. So we'll quickly take note of that. So we'll say AB is equal to 8 centimeters. Okay. So now let's have a look at our triangle and see if we can now work out the area of this triangle. So I'm going to just draw this up like that. And so we know we've got O, A, B. We know that that is 8 centimeters. I know that these two angles are 72. And I know that this angle here is going to be 36. So just as a quick reminder, for us to be able to figure out the area of a triangle, we need to have the formula half times A, which is a side length, times by B, another side length, times by sine of the angle C, which is going to be the interior angle between sides A and B. So clearly what we're missing here now is just one of the other side lengths. So we can actually remember and recall that since this is an isosceles triangle, that both of these side lengths, OA and OB, are going to be the exact same. So we might just call that R for now, sort of to treat it like it's some sort of radius. Okay, so now how would I figure out our length R? Well, now we actually turn to our sine rule. So we can say that R over sine of 72 degrees is going to be equal to 8 over sine of 36 degrees. Okay? And so now solving for R, we see that R is equal to 8 sine 72 degrees over sine of 36 degrees. And so now computing that, we get a distance of about 12.94 centimeters. Okay, fantastic. So let's quickly put that into our diagram over here on the left. So we'll say that this is now 12.94 and 12.94 over here as well. Okay, so now we know every single side length and every single angle on this triangle. So what we can do now is figure out the size of this triangle in terms of its area. So again, by using this formula here. So now we might want to say that maybe A is going to be the side length AB, and maybe B will just be one of the other side lengths. They're both the same, so it doesn't really matter here. So putting those values into our formula now, what we get is that A, the area of the triangle, is equal to half times by 8 times by 12.94, and now times by the internal angle between A and B, which is going to be sine of 72 degrees. Okay, and now putting that into your calculator, what we get is it's about 49.24 centimeters squared. However, since this is a decagon, how many of triangles do we think we'll have inside? Well, we'll have 10 different triangles inside this shape here. So what we need to do now is we need to simply multiply this number by 10, and that will give us our final answer to this problem here. So now we can say total area is going to be equal to 49.24 times 10, which is just going to be 492.4 centimeters squared. And that's our value for the entire area of the inside of this decagon. Okay, so a bit of a tricky question there. Now, moving on to question 23. So a continuous random variable x has the following probability density function. So f of x is equal to sine of x when x is between 0 and k, and 0 for all other values of x. So the first thing we need to do is find the value of k. So what we know about probability density functions is that when we integrate them, we must get a total area of 1. So now what we can say is that 1 is going to be equal to the integral of f of x dx from 0 to k, since that's the domain where this will actually take a value. Okay, so now simply looking at this, so what's the integral of sine of x? Well, the integral of sine of x is equal to minus cos of x. And now what we need to do is sub in our different values from k and 0. And what we'll find now is that 1 is equal to minus cos of k. And then cos of 0, well, it's just going to be 1, but it will end up being minus 1, so just be a plus 1 here. And so now what we get is that we'll subtract the 1 from both sides, and then we're left with cos of k equals 0. So now we just need to determine, well, when does the cos function equal 0? Well, we know that the cos function equals 0 at pi on 2. And that's going to be our answer here. So we can say, therefore, k equals pi on 2. And you can just simply find that out as well by just taking the inverse cosine of both sides here. Okay, and that's part A. Now on to part B. Find the probability that x is less than or equal to 1, and give your answer correct to 4 decimal places. Okay, so again, it's going to be the same sort of formula here, but now we don't know the area. So now we're just looking at the integral of f of x dx from 0 to 1. And so now we know that that's just going to be equal to minus cos of 1 plus cos of 0. Okay, and so make sure that you're using radians here when you put this into your calculator. If you put in degrees, I don't think you'll get a very sensible answer at all. So make sure, yeah, you are using radians here. And so just simply putting that into your calculator, you will get a value of 0.4597. Okay, and that's question 23. Now on to question 24. The circle x squared minus 6x plus y squared plus 4y minus 3 equals 0 is reflected in the x-axis. So sketch the reflected circle showing the coordinates of the center and the radius. Okay, so what we need to do first is probably just quickly work out what this normal circle will look like. So what I'd recommend doing here is, first of all, we'll move that 3 to the other side. So now our equation will look like this. So x squared minus 6x plus y squared plus 4y equals 3. And so remembering now the way that we approach our circles is essentially by completing the square. So what we'll end up doing here is we halve each of these numbers, and then we'll square whatever that value is, and that's what we add to our numbers here. So what that will look like now is x squared minus 6x, and then half of minus 6 is going to be minus 3. Minus 3 squared is positive 9, so we'll say plus 9. Now plus y squared plus 4y. Half of 4 is 2, so 2 squared is 4. And since we've added that to the left-hand side, we now just need to add those to the right-hand side as well. So now it becomes 3 plus 9 plus 4. Okay, and since we've now completed the square on the left-hand side, we can now rewrite this out as x minus 3 all squared plus y plus 2 all squared equals to 16. Okay, so looking at this now, that will give us a center of a positive 3 and a negative 2 with a radius equals to 4, right? So just taking the square root of that, that gives us our radius. But since we know we're reflecting it in the x-axis, that now means that instead of having a negative y value of negative 2, we'll actually end up with having a positive value. So now after reflection, this is going to be our center. Okay, so now quickly drawing this up, let's have a look at this. So center is going to be at 3, 2, so maybe around here. And we know that there's a radius of 4. So I'm going to draw that roughly like that. There we are, give or take. And now we'll just quickly note that the radius equals 4. And we'll say that this point here is 3, 2. And don't forget to label your axes, x and y. And there we are. So that's our circle there. All we needed to do was sketch that. And there we go. Now on to question 25. So a landscape gardener wants to build a garden bed in the shape of a rectangle attached to a quarter circle. Let x and y be the dimensions of the rectangle in meters, as shown in the diagram. Now, the garden bed is required to have an area of 36 meters squared and to have a perimeter which is as small as possible. Let p meters be the perimeter of the garden bed. So what we need to do first is show that p, the perimeter, is going to be equal to 2x plus 72 over x. So the first thing I'll do actually is just look at this general sort of shape and start thinking about what will the perimeter be in most basic form. So I can write that now up the top. So the perimeter, let's see, we've got x plus y plus a y. This is also going to be x down here since that's the same as the radius there. And then we have this arc length over here. So now the perimeter is going to be equal to 2x plus 2y. And now what does a quarter of a circle circumference look like? Well, our usual circumference formula is 2 pi r. So now I'll write 2 pi x, since that's the radius of the circle. However, now we're going to be dividing it by 4 since we have a quarter of a circle. And so now I can just quickly simplify this all out. So now it looks like 2x plus 2y plus pi x over 2. Okay, so that's our perimeter in its most basic form. Now let's look at what else can we tell about this shape. We know the area must be equal to 36 meters squared. So let's quickly write that up. So area equals 36 meters squared. What else does the area equal to? Well, looking at our diagram here, we have two different areas. So A1 for our rectangular section and A2 for our quarter circle section. So I can say now that A1 is just simply going to be equal to x times y, and A2 is going to be equal, so what's the full area of a circle? That's pi r squared, so that would be pi x squared. But now since it's a quarter of a circle, we'll put that 4 on the bottom there. Okay, so that means that we now have a formula. 36 meters, since that's the area, is equal to xy plus pi x squared over 4. Okay, so now what we need to do is start looking at these two equations that we have over here. So we've got equation 1 and equation 2. So what I think we should do is try and solve equation 2 for our variable y, so that way we may substitute that back into equation 1, since we know that they want the perimeter in the form where we only have x values in there. So now solving equation 2 for y, we get that y is equal to 36 minus pi x squared on 4. And now what we need to do as well is we'll simply divide both sides by x. And so what we get now is 36 on x, and then we'll change that from an x squared simply into an x. Okay, so now what we'll say is we'll sub that into equation 1. And what we have now is that the perimeter P is equal to, what do we have? We've got 2x plus 2y. So now instead of writing y, I'll replace it with this section here. 36 on x minus pi x on 4. And then plus pi x on 2 at the end there as well. Okay, so now expanding this bracket, we get Well, we have the 2x out the front, and now 2 times 36 is 72 over x. And then 2 times minus pi x on 4, that will just become minus pi x on 2, which will then cancel out with the plus pi x on 2. And there we are. So that's exactly what we were looking for, as asked in part A here. Okay, so now part B. Find the smallest possible perimeter of the garden bed, and we need to then show why this is the minimum perimeter. So anytime you see the words minimum or maximum in a problem like this, you should know that you're always going to want to start looking at your derivatives. Okay, so the first thing that we'll do is we will take a formula. We'll quickly rewrite it. So P equals 2x plus 72 over x. Now let's take our first derivative. So dp dx is now just going to be equal to 2 minus 72 over x squared. Okay, so what do we know now about this formula here? Well, we know that we want to have this at a minimum. So we know that therefore that means that we want to have dp dx equals to 0. So let's quickly see what that will become now. So now we'll have 0 equals 2 minus 72 over x squared. So essentially what we want to do is we just want to have 72 over x squared equals to 2. So the way that we can get that to actually occur is we can just quickly rearrange this, and what we get is that x squared equals 36, so therefore x equals 6. Okay, so that's our x value there. So what we need to do now is use that to be able to then figure out what will the total perimeter be. So now we can say that P, the perimeter, is going to be equal to 2 times 6 plus 72 over 6. And so that gives us a net value now of 24 meters. Okay, so now what we need to do is we actually need to show that this is a minimum point. So now to show that something is a minimum, what we need to do is now look at the second derivative. So we'll take d squared p over dx squared. And so now differentiating this one again, well, what do we get now? We get that it's going to be positive 144 over x cubed. And so now what we see is that if I take the second derivative at that point, where x is equal to 6, I'll quickly write that out properly. So d squared p over dx squared of when x is equal to 6, well, we get 144 over 6 cubed. And we know that that must be greater than 0. So therefore, we can say, therefore, local minimum. And so now that we've found the perimeter, and we've also clearly shown that it must be a minimum through our calculus skills, we can then just conclude there on the statement by saying that the smallest perimeter must be 24 meters. And there we go. So that's question 25. Now on to question 26. So Tina inherits $60,000 and invests it in an account earning interest rate of 0.5% per month. Now each month immediately after the interest has been paid, Tina withdraws $800. The amount in the account immediately after the nth withdrawal can be determined using this recurrence relationship here, where n is just simply going to be integer numbers. And we know that the initial amount, a sub naught, is simply going to be $60,000. So use the recurrence relation to find the amount of money in the account immediately after the third withdrawal. Okay, so all we need to do here is start working with this recurrence relation and start working it through it like this. So a sub 1 is going to be equal, so looking at this, it will be a sub 0, which we know is just simply 60,000. Now times by 1.005, then minus 800. And so calculating that, we get 59,500. Okay, so A2. Well, now instead of having 60,000 out the front, we'll now have 59,500. That's going to be multiplied now by 1.005, and again, minus 800 on the end there. And so now calculating that, we get a value of $58,997.50. And now for A3, so this is going to be the answer for this question. We'll say that A3, the amount of money left in the account immediately after the third withdrawal, is going to be equal to $58,997.50. $997.50, multiplied now again by 1.005 minus 800, and that will give us a value of 58,492.49. And don't forget our $sign for our answer there. Now, for question B, it says calculate the amount of interest earned in the first 3 months. Well, we know that she's taking out $800 each month. So what would we expect? We would expect that the total amount should go from 60,000 minus, now, how much is 800 for 3 months? That would be 2,400. So we would expect it to now have a total amount of 57,600. But what we see here is actually that it's at 58,492.49. So what that means here is that the difference between the true value and the expected value with what we've been taking out, that's going to be the amount of interest that we've earned through this investment here. So now we can say that, yep, 58,492.49 minus 57,600. That will give us our answer for our total interest. So I'll put a big I there for that, of $892.49. And that's our answer for part 2. Now, going on to part C. Calculate the amount of money in the account immediately after the 94th withdrawal. So this is definitely going to be one of those questions where we can't just sit here and go A0 equals A1 equals A2 equals ... all the way down to A sub 94. That would take far too long to do that. So what I propose we do instead is we start looking at the patterns emerging from the other different values that we've already seen. So what we can do is we can rewrite A1 simply as 60,000 times by 1.005 minus 800. Okay, and that's pretty straightforward. That's exactly what we had earlier. But now what I can write for A sub 2 is going to be equal to 60,000 times by 1.005. And now I'm going to square that. And now I'm going to say, well, what's the interest accrued on the $800 that we've taken out? Now that would be minus 800 times by 1.005. And then again, minus the 800 that we take out at the end of each month. And so what we see now is that we're starting to develop a bit of a pattern here. So we see that this will now essentially boil down to be a geometric progression. So what we can now say is that A sub 94 is going to be equal to 60,000 times by 1.005, now to the power of 94, minus 800 times by 1.005 to the power of 94 minus 1 over 1.005 minus 1. And this is just coming from our geometric progression, the sum of a geometric progression formula. So we should have this on our formula sheet, I believe, or we should at least be comfortable with this before going into our HSC. And so when we actually calculate that, that now comes down to be $187.85. And there we go. So that's our final answer for question 26C. Now, moving on to question 27. It's a bit of a long question here. So, a cricket is an insect. The male cricket produces a chirping sound. So a scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. So once a day for 20 days, the scientist collects data based on the 20 data points the scientist provides the information below. So a box plot of the temperature data is shown. The mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. So what I think we should do is probably write that down right now. So what I'll say is that the mean temperature, so I might just note that as T with the bar on top for the average, is now just going to be equal to a median minus 0.525. So our median here is 22, since that's what that mark in the box plot represents. So now it's going to be 22 minus 0.525. Okay, so in other words, the average temperature is just going to be equal to 21.475. Okay, now let's keep going with the rest of this question. So a total of 684 chirps were counted when collecting the 20 data points. So what I think we should do now with that information is now maybe work out the average chirps per data collection. So maybe we'll say that C, the average C, is going to be equal to 684 divided through by 20. And so that gives us a value of 34.2. Okay, let's keep reading now. So the scientist fits a least squares regression line using the data, x and y, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. The equation of the line is y equals minus 10.6063 plus bx, where b is the slope of the regression line. So what I think we need to do real quick is now, instead of writing this as t average and c average, we'll quickly write that now as the x average and the y average, since they've now told us that x is going to be temperature and y is the number of chirps. So the least squares regression line passes through the point x average and y average. Fantastic. So where x average is the sample mean of the temperature data and y average is the sample mean of the chirp data. Fantastic. So we've already calculated those two, so we should be in a pretty good spot to solve this problem now. So now it asks us to calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius, and give your answer correct to the nearest whole number. So before we can even figure out that part there, what we need to do is we actually need to go through and figure out what b is going to be. So they have tried to trick us a little bit here, since we know that normally for the equation of a straight line it's y equals mx plus b. So they've just kind of chucked that around the other way to just be a little bit of a confusing problem. So now to solve for b, well, since we know that it passes through x average and y average, we can just simply sub those coordinates into this formula and then rearrange and solve for b. So doing that now, we'll see that 34.2 is equal to minus 10.6063 plus b, the slope, times by 21.4475. Okay, so now quickly solving for b, so we get that b is equal to 34.2 plus 10.6063 divided through by 21.475. And that will now give us a value of about 2.08644. Okay, so now that we know that value, now we can actually approach this actual problem here. So now calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius, and we need to give it to the nearest whole number. Okay, so now putting all this into our equation here, number of chirps is y, so we know that y must equal now to minus 10.6063 plus b's value is now 2.08644 times by our x value, which we know is given here as 19 degrees Celsius, so we'll put in 19. Okay, so now putting that into a calculator and then rounding it to the nearest whole number, we simply get 29. So we can say 29 chirps is going to be our final answer there. And that's question 27. So now moving on to question 28. So in a particular country, the hourly rate of pay for adults who work and is normally distributed with a mean of 25 and a standard deviation of $5. So two adults who both work are chosen at random. So now find the probability that at least one of them earns between $15 and $30 per hour. Okay, so what we need to look at here is we need to start looking at our normal distribution. So I'm going to draw it out like that. So we know that our mean is going to come right in the middle here, so that's 25. We know that maybe one standard deviation is probably going to be about here, so that would be 20, and 30 over here, since the standard deviation is 5. We'll put the next ones in as well, so that would now be 35 up here, and maybe 15, I think maybe a little bit further over there, there we go, 15 around there. So now what it's asking is, it's saying, well, what is the probability that at least one of them earns between 15 and $30? So that means essentially, what is this area? All the way from 15 up to 30. And so what we know about our standard deviation and our normal distribution is that with the empirical rule, we can say that within one standard deviation, we'll have essentially 34% of data to the left and 34% of data to the right. And then we can also say that going the extra standard deviation after that, so going 2 standard deviations, that will add on another 13.5% of all of this data into that section there. So now all we actually need to do here is we need to look at the probability of them being in this space here. So the probability that someone earns between $15 and $30, I'll quickly write this out in proper notation, is going to be probability of 15 less than x less than 30 is going to be equal to 34 plus 34 plus 13.5%. So that's going to be 81.5%, or I'll write it as 0.815. Okay, so now to look at the probability of at least one of them earning between those, what I think it's probably better to do is to first look at the probability that neither of them earn between those different sections there. So to figure that out now, it's going to be a little bit easier. So we can say that that probability is going to be equal to 1 minus 0.815. And then this is going to be for the chance that one person does not work in that area. And then we're taking that off from 1 to figure out the chance that someone does work in that area. And now we have two different people here as well. So we need to now square that probability there. And so when we do that, we actually end up with an answer of 0.965775. And there we go. So that's our answer for part A there. Okay, now moving on to part B. The number of adults who work is equal to 3 times the number of adults who do not work. One adult is chosen at random. Find the probability that the chosen adult works and earns more than $25 per hour. Okay, well, from this, the probability that someone works is going to be 3 and 4, since 3 times more people work than do not work. And then we need to start looking at the probability that someone earns greater than $25. So since that's the mean, well, to earn greater than 25, it's simply just going to be equal to 50%. So we can say that probability of x being greater than 25 is equal to just 1 over 2. And so now to figure out total probability here, we can just say that the p is going to be equal to 3 on 4 times by 1 on 2, which is going to be equal to 3 over 8. And that's your answer there for question 28. So not a very difficult question if you know what you're doing and you're familiar with the empirical rule. So now moving on to question 29. So the diagram shows the graph of y equals c ln of x, where c is greater than 0. So for part A, we need to show that the equation of the tangent to y equals c ln of x at x equals p, where p is greater than 0, is y equals c over p x minus c plus c natural log of p. Whew, okay, so an absolute mouthful of a question there. So what it's asked us to do essentially is start off by just finding the gradient, and then we can work out the tangent. And so that's nothing that we should be too uncomfortable with. So y prime. So if y equals c times ln of x, then we know that y prime is simply just going to be c over x. Okay, so nothing too crazy there. And we know that if this is going to be at the point where x equals p, we can say that y prime of p is simply going to be equal to c over p. And there we are. So that's, again, nothing too crazy there. So now what we know is we want to create the equation of the tangent to that, at that point where x equals p. So to create the equation of the tangent, what we always need to kind of refer back to is our point gradient formula. So y minus y1 equals m outside of x minus x1. And so here we have that m is just going to be that gradient that we've just found. And we can quickly figure out our x1 and y1. So x1 is simply going to be our x value coordinate here. So x1 equals p. And we know that y1 is going to be equal to c times the natural log of p. Okay, so now putting all this data into our point gradient formula, we see that y minus y1, which is c ln of p, is equal to m, which is now c over p, times by x minus x1, which is now p. Okay, so what I think we need to do here is quickly expand those brackets, and we'll add the c ln p to both sides as well. So we can say, therefore, y is equal to cx on p, and then it will be c over p times by p, so that's just going to be minus c. And then we've added that c ln p to the other side, so now just plus c ln of p. And that is exactly what they've asked for. So that's our answer for part A. Now for part B, it says find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. Okay, so what that means now is that we know that c over p, that gradient, is going to be equal to 1. So in other words, c equals p. So now again, working with that previous formula that we have, we can then find that minus c plus c ln of p is going to be equal to 0, since we know that it must pass through the origin. So now all we need to do is remember that p is equal to c, and then we can start solving this and see what we get. So I'll quickly rewrite that now as ln of c. So maybe we can take out a common factor of c, and then we'll be left with c outside of ln of c minus 1 is equal to 0. So from here we can determine that either c equals 0 or ln of c is going to be equal to 1. And now the only way that the natural log of any number can be equal to 1 is if it's going to be the same number in here as the base of that logarithm. So clearly that means that c must be equal to e. And since we have in the question given that c is greater than 0, we can therefore eliminate that option there, that c equals 0, so we know that we must have the value of c equals e. And that's our final answer for 29b. Okay, now moving on to question 30. So the diagram shows two parabolas, y equals 4x minus x squared and y equals ax squared, where a is greater than 0. Now these two parabolas intersect at the origin and at point A. So we need to show that the x-coordinate of capital A is 4 over a plus 1. So essentially all we're doing is we're just solving simultaneous equations here. So we can say that y equals 4x minus x squared, and that will be equation 1. And then equation 2, we have y equals a x squared, and that's equation 2. Okay, so now setting these equal to each other, we get that 4x minus x squared is going to be equal to ax squared. And now let's start rearranging this and solving this. So I might bring the minus x squared to the other side, so that way it remains positive. Then I can write this as a plus 1 after factorizing it of x squared minus 4x is going to be equal to 0. Okay, so now I can look at this and I can actually factorize this again. So now I can take out a common factor of x here. So now I can rewrite this whole thing out as x out the front of a plus 1 in brackets x minus 4 equals 0. So now from looking at this, we can say therefore x equals 0 or x equals to 4 over a plus 1. And that is exactly what part A is asking us to find. Okay, so now for part B. Find the value of A such that the shaded area is 16 on 3. Okay, so we know that to find the area of this section here, we're going to be using integration. So we can say that A, the total area, is going to be equal to the integral from 0 to that point there, 4 over a plus 1, of our two equations. Now, which one is on top? Well, we see that the one with the minus x squared is going to be the parabola that's concave down. So that means that that's the parabola on top. So that's going to be the one that comes first here. So we'll write that out now as 4x minus x squared. And then what we do with the other parabola, the concave up one, is we then want to subtract that from this. So now we'll say minus ax squared. And this is all going to be dx equals now to 16 on 3 as it was given here. Okay, so now let's go through and quickly start integrating some of these problems. And let's see what we get. So we should end up with, I believe, 2x squared minus x cubed over 3 minus ax cubed over 3. And we're going to be taking values from 0 up to 4 over a plus 1. We know that again, that's equal to 16 on 3. Okay, so what we can do here is we can actually start factorizing that inside of this bracketed term here. And what we should also recognize is that if we are substituting in the 0 value, the whole thing's just going to be 0. So we can pretty much ignore that part for now. And so now let's quickly factorize that. So what do we get? We'll end up with a 2x squared minus, and then brackets a plus 1 x cubed over 3. And I'll just put in the top 4 over a plus 1. And again equals 16 on 3. Okay, so now let's actually make that substitution of the 4 over a plus 1 into the x values. And so what we're left over, or what we have left over I should say, is 2 times 4 squared over a plus 1 all squared minus a plus 1 times by 4 cubed over 3 times by a plus 1 all cubed, again equals to 16 on 3. Okay, so I'm going to go ahead and bring this up to the top right hand side now. So expanding these brackets and figuring out what these numbers actually are. So 4 squared is 16, so 16 times by 2 is going to give us 32 over still a plus 1 squared. Now minus by a plus 1 over the a plus 1 all cubed. I'm going to ignore that now, so we'll just get rid of that. And so now it's going to become 4 cubed. So 4 cubed is 64. Our denominator here is now just going to be 3 a plus 1, and since we've cancelled out one of the a plus 1s, it now becomes a plus 1 all squared equals to 16 over 3. So what we can do here is quickly multiply every single term by 3 times by a plus 1 all squared. And so what we get then is 96 minus 64 is going to be equal to 16 out the front of a plus 1 all squared. And now we have 96 minus 64, so that's just going to be equal to 32. So now 32 equals 16 out the front of a plus 1 all squared. And now quickly solving this, we should find that a plus 1 all squared equals 2. So we can say therefore a equals the square root of 2 minus 1. And that is our value of a, such that the shaded area is 16 over 3. So now moving on to question 31. Now, the population of mice on an isolated island can be modeled by the function of m of t equals to a sine of pi over 26t plus b, where t is the time in weeks and t goes from 0 through to 52. The population of mice reaches a maximum of 35,000 when t equals 13, and a minimum of 5,000 when t equals 39. So the graph of m of t is shown. So part A asks us, what are the values of A and B? So we know that according to our formula here, A is going to be the amplitude of this sinusoidal wave. So to work out the amplitude, what you want to do is you want to look at the difference between the highest point and the lowest point. So we can say that therefore A is going to be equal to 35,000 minus 5,000, and we just divide that by 2. And so that will give us a value of 15,000, so that's A. And for B, well, that's just going to be our y-intercept. So we know for a sinusoidal wave, the y-intercept is going to be right in the middle of the maximum and the minimum. And so here, since we know that the value starts at 15,000, well, it's going to be 15,000 above 5,000 or 15,000 beneath 35,000. Either way you look at it, you'll still get the same result of B equals 20,000. Okay, so that's part A, all sorted there. Now for part B. On the same island, the population of cats can be modelled by the function c of t equals minus 80 cos of pi on 26 times by t minus 10 plus 120. So now what we need to do is consider the graph of m of t and the graph of c of t and find the values of t such that both populations are increasing. So we already have the graph of m of t, so let's quickly try and draw up the graph of c of t. Now, I'm not too fussed about the actual axis values, but as long as we can get the rough shape of this graph, I think we should be pretty well set. So since it's going to be a cosine function, and we know that it starts with a minus, that means that we'll start by heading downwards, and then by going upwards, something approximately like that. But since we know that we are also shifted over by 10 units, so what does that mean for us now? That means that our now minimum is going to be when t is equal to 10. So what I can say now is that this will probably look a little bit something like this. There we go. So as I said, I'm not too fussed about the actual numbers going onto this graph, but we should quickly probably put down that that's going to be t, and this is going to be c of t, so our cat population here. So as I said earlier, that means our minimum must be at t equals 10. And now let's have a quick look. So where would our maximum be? Well, if we have a quick look at this equation and we want to solve for the maximum, well, we know where we can find the maximum on cosine. So that's going to be 3/4 of the way through for this particular cosine here. And so the value that will actually correspond to this is going to be t equals 36. So now we have two different values for the minimum and the maximum. And now let's see, how does that actually relate to the question? So it's asked us to find the values of t such that both populations are increasing. So what we know about our cat population now is that it's going to be increasing from t all the way up to, from t equals 10 all the way up to t equals 36. But after t equals 36 and before t equals 10, it's decreasing. So what we can say here is that for the cat population, it's going to be when t is greater than or equal to 10, or less than or equal to 36. Okay, perhaps we shouldn't actually say equal to, as that would have a gradient of 0, so we should probably just leave it as less than and greater than here. So now we have our range for the cat population. Let's have a quick look back at our mice population. So where is the maximum point here? Well, it's told us at t equals 13. So that's over here. And then when t equals 39 for our minimum point there. Okay, so let's see, where does this correspond? Because now we know that that's decreasing from 13 through 29. So the only point where this is increasing is now after 39. So we can say it's increasing when t is greater than 39, or when t is less than 13. So do either of those correspond to our value that we had just found earlier? Yes, and ever so slightly so. So now we can say that both populations are increasing when t is between 10 and 13. So we'll say t is greater than 10 and less than 13. So that's going to be our answer for part B there. So it's a good 3-mark question there. Now moving on to the very last section of this exam, it says, find the rate of change of the mice population when the cat population reaches a maximum. So we've already identified that the cat population reaches a maximum at t equals 36. So what we need to do now is we just need to see, well, what's the rate of change? That just means we're looking for our first derivative. Okay, so we're looking for m prime of t when t equals 36. Okay, so what that means for us now is let's figure out m prime of 36. So let's go back and look at our original function. So we know that the mice population is equal to 15,000 sine of pi over 26t plus 20,000. So let's quickly write that down first over here. So we'll say m of t equals 15,000 sine of pi on 26t plus 20,000. Okay, so now quickly differentiating that, let's see what we get. We'll have that m prime of t is going to be equal to, so when we differentiate this, this will come out the front, and this sign will change into a cosine. So now it's going to be equal to 15,000 times by pi over 26. Now cosine of pi on 26t, and that 20,000 will just disappear. So now looking at this rate of change, again, as I mentioned earlier, all we need to do is set t equals to 36, and let's see what we get. So we're now saying that m prime of 36 is going to be equal to 15,000 times by pi on 26, now times by cos of pi on 26, times by 36. Okay, and so now putting that into your calculator, what we get is a value of minus 642.7. And so since we know that we can't decrease the population by 0.7, we'll round that, technically rounding that down to the minus 643. So minus 643 mice per week. And that is our final answer to the 2020 Advanced Mathematics HSC. So thank you very much for watching. So whether you've gone through the entire exam with me or whether you've just had a look over at a few different questions that you found difficult, I wish you all the best of luck going forward with your studies. And if you have enjoyed the video, please like, subscribe, comment, and let me know down below what you'd like to see a bit more of, and if I can elaborate on any other topics, I'd love to know. Anyways, I'll see you next time.